Imagine this. Your new AI assistant just wiped the company's entire customer database. It wasn't a malicious attack. It was just trying to be helpful. This is the new and kind of unpredictable risk of AI tool misuse. It's a danger that every organization adopting autonomous systems really needs to get a handle on. See, this isn't about hackers. It's about a well-intentioned AI causing total chaos because it's missing one critical thing: common sense. So let's break down what's really happening here.
This analogy just hits the nail on the head, doesn't it? You give a simple command, clean up your inbox, and the AI executes it with perfect but terrifying logic. I mean, the cleanest possible inbox is an empty one, right? It just doesn't get the implied human context, that you obviously want to keep the important stuff. And that right there is the core challenge we're all facing. How do we use the incredible power of AI without opening the door to catastrophic and totally unintentional business risks?
So that email analogy really sets the stage for what we're talking about, which is a whole new category of risk. This is not about the traditional software bugs or security flaws that we've spent decades learning how to manage. Nope. We are dealing with a fundamentally different kind of behavior, one that comes directly from the probabilistic nature of modern AI.
And what's really crucial to understand here is that AI tool misuse is not about malice. The agent isn't turning on you. It's about the agent completely misunderstanding your instructions or maybe misinterpreting a goal you gave it. It could even be tricked by a hidden command it can't tell apart from a legit one. It's simply trying to do its job, but its definition of that job can lead to some truly disastrous outcomes.
This really highlights the huge difference between the old world of software and this new world of AI. With traditional code, everything is deterministic. You put the same input in, you get the same error out every single time. Its logic is basically written in stone. But AI agents, they're probabilistic. Their actions are based on these super complex patterns they've learned from massive data sets, which means that even the people who built them can't fully predict every single move they might make.
Now, to really manage this risk well, we have to get precise with our language. You're going to hear another term thrown around a lot in this space: excessive agency. In fact, the OWASP Top 10 for LLMs flags it as a major risk. So it is absolutely vital to understand how it's different from tool misuse. Let's break that down. Okay, this distinction is critical, especially for security managers. Excessive agency, that's a design flaw. It means you are giving the AI way too much power right from the start, like letting a bot issue unlimited refunds. That's a failure in architecture. Tool misuse, on the other hand, is an operational flaw. This is when the agent has the right permissions, but it uses them in the wrong way.
And here's why that distinction matters so much. While they are two separate issues, they have a really dangerous relationship. Think about it. An agent with minimal permissions can only cause minimal damage. But an agent suffering from excessive agency, when that agent misuses its permissions, the blast radius can be absolutely catastrophic.
All right, enough with the theory. Let's talk about how this stuff actually plays out in the real world. Here are the 6 most common ways an autonomous agent can turn its legitimate tools into instruments of, well, damage.
You've got everything from prompt injection, where a hidden instruction tricks the AI, all the way to goal corruption, where the AI just misunderstands its objective with disastrous results. The pathways to failure are, well, numerous. We're going to focus on 2 of the most subtle and dangerous scenarios: tool chaining and resource exhaustion.
This slide breaks down a really insidious risk called tool chaining. So, imagine an agent with 3 simple and what look like pretty safe permissions. It can read local files, it can search the web, and it can send emails. Each of these, if you look at them in isolation, seems like a low-level risk. But a smart enough AI can chain them together.
And that's the danger in a nutshell. By combining 3 low-risk actions, the agent has effectively created a brand new, high-risk capability for itself: data exfiltration. This is exactly why looking at tool permissions in isolation is just a recipe for disaster. You have to think about the combinations. Okay, here's another scenario that's all too common: API abuse. An agent is tasked with, say, following up on a list of 100 customer tickets. It hits a snag on the very first one, but because it doesn't have the common sense to stop or ask for help, it just retries the API call again and again and again. Before you know it, it's hammered a service with tens of thousands of requests, racking up a huge bill, and maybe even causing a denial of service condition.
And that brings us to this really fundamental question: when does a helpful agent know when to stop? The scary answer is, it doesn't. Not unless you explicitly tell it to. We just cannot assume these systems will have some kind of human intuition about boundaries or when it's time to give up.
They need hard-coded limits and rules.
Okay, so we've looked at the problem from a few different angles. It's complex, it's dangerous, and it's only going to become more common as AI gets woven deeper into our operations. But it is manageable. The key is to stop thinking about a single point of defense and start adopting a strategy with multiple layers of containment.
So effective protection really requires these 4 overlapping safeguards. You can think of it as defense in depth, but for AI. Each layer is designed to catch failures that might slip through the others. And remember, no single layer is a silver bullet. They have to work together.
Let's start with the foundation. Layer 1, the principle of least privilege, is basically Security 101, right? Don't give the agent any permission it doesn't absolutely need for its job. Default to read-only always. Then, Layer 2 is sandboxing. You have to assume the agent will go rogue, and make sure that when it does, the damage is contained. Isolate it from your production environment. Use temporary credentials that expire, and set hard limits on what it can consume.
Now for the active defenses. Layer 3 is your most powerful immediate control. Approval workflows. For any high-risk action, deleting data, spending money, writing to external systems, you have to require a human to click approve. Honestly, this one step prevents most of the catastrophic outcomes. And finally, Layer 4, monitoring. You can't stop what you can't see. Log every single tool call and set up alerts for any suspicious activity, like those loops or sudden cost spikes.
So we have our 4-layer strategy. But look, you don't need to build a fortress to protect an agent that just summarizes internal documents. The key here is to match the intensity of your controls to the level of risk that a specific agent actually represents.
This table gives you a pretty practical framework. So, for a low-risk agent that's just searching your internal knowledge base, some basic sandboxing and rate limiting is probably fine. But for a critical risk agent with broad access to production systems, well, you need the whole shebang. Every single layer of defense, plus real-time monitoring, and a documented incident response plan that you've already practiced and are ready to execute at a moment's notice.
So, let's bring it all home. First, remember that tool misuse is an operational flaw. It's the wrong use of the right permissions. Second, you have to be on the lookout for those insidious risks like tool chaining and resource loops. Those are the silent killers. Third, implement that 4-layered defense strategy. It's essential. And finally, always design for failure. Just assume something will go wrong, because eventually it will. And when it does, you need to be ready to roll it back.
We'll end with this thought. And this isn't some theoretical exercise. As you deploy more and more of these autonomous agents, this becomes one of the most important questions your security team can ask. If your agent went rogue tomorrow, would you even know it was happening? And if you did, could you stop it before it caused real, significant damage? If the answer to either of those questions is, I don't know, or just no, then you know exactly where you need to start.